The purpose of this video is to introduce you to the concepts of work and kinetic energy in physics. So this video will enable you to define and calculate the work performed on an object, which is different than work you might have defined in the past, and relate work to kinetic energy. Hopefully you recognize that movie. So, let's define work to start. Here is the formula for work. Work is defined as force acting on an object over a distance. Mathematically, we can say that work equals the net force applied to an object times the distance that the object moves times a cosine of the angle at which the horizontal force is being applied. Take a moment, write down that equation, highlight it in your notebook. That's an equation you're going to use for the next couple weeks at least. Let's derive the units for work. So we know that this is net force, and net force is newtons. Distance is measured in meters, and the cosine of an angle has no units. The units are degrees, but that's not a measuring unit in terms of force or distance, so we're not going to take those into consideration. So the units for work are called the Newton meter. And the other way we can say this is that the Newton meter is also considered the joule. And you may have talked before in other science classes about the joule being a measurement for energy. Two important concepts here. Work happens parallel to a force exerted on the object. So if the object is moving left and right, work will happen left or right. This is why we use the x component of the force, or the cosine of the angle, because remember that the cosine function goes with the horizontal x component. Work can cause an object to slow down or speed up, depending on the direction the force is being applied. Here's an example of that. So we have this SUV, and the black vector down here represents the direction the car is going. So the car is going from my left to my right. So we're going to call that the direction. Well, let's say here that I'm going to apply a force this way. Well, that force is being applied at an angle, and that angle has a force in the x direction and a force in the y direction. And the force in the x direction runs parallel to the direction the car is going. So in this particular case, the force and work acting on the object is going to be positive because the force in the x direction is moving the same direction as where the car is moving. Now let's look at a different example. Let's say that this car is still moving from my left to my right, but this time, say that there is some sort of external force going this way. In this particular case, I'm going to have an x component to my force that is going to be parallel but going the opposite direction of my displacement. So my work is going to be Fx times my displacement, but my Fx component is going to be the cosine, and since I'm going the opposite direction, I'm going to have to make this value negative, and it's going to be times by the distance, so that my final overall work component will be negative. So in this case, the work being done upon the car is going to cause the car to slow down. We're going to get to practice with that next. So I want you to stop for a moment, pause the video, and I want you to think about these three examples. So is network in the scientific sense, which is force times distance, happening in the following examples? Explain why or why not. A is the students had to work hard to do as well as they did on the last physics test, which is true, everybody did really well. B says two dogs are having a tug-of-war with a rope, neither is winning. And C is a car is traveling at constant velocity. Think about if any of these scenarios work is being done in the scientific sense. Pause the video and then come back. So at this point, hopefully you paused the video, came back, and realized in scenario A, the answer is no, because the work that the student is doing is not equal to force applied at a distance. Now, the pencil was doing work to the paper when you were answering your physics questions. However, your metaphysical work is not the same as the physics term work that we're talking about in this video. B says two dogs are having a tug-of-war with a rope. Neither dog is winning. So again, I'm not going to draw a dog because I can't draw. But I've got dog 1 pulling this way, dog 2 pulling this way, and I have to recognize, since neither dog is winning, the net force is going to be nothing. So if the net force is nothing, no work is being done, because force times distance is work, 0 times, and their dogs aren't moving anywhere, 0, that's going to be 0 work being done. The last one, car traveling at a constant velocity. Well, hopefully you recognized that that car is experiencing a state of inertia where all the forces will balance each other out. And since all those forces are balancing each other out, there is no net force. So remember, force has to be work times distance, 0 times who knows what distance, but that's still going to be 0 work being performed. So the purpose of these three scenarios is to show you that work will only happen if there is a net force acting upon the system, and that force is acting over a distance. Here's an example for you. Your chore is to mow the lawn during the summer months. When mowing the lawn, you mow 10.0 meters across in one passing. You apply a force of 70.0 newtons at the 46.5 degree angle with respect to the lawn. How much work have you done in one passing? So here's my picture of who knows who mowing the lawn. You can decide who that looks like. And I'm going to notice here that you are pushing the lawnmower at a 46.5 degree angle. And I notice that there will be a y component to your force and an x component to your force. I know that my overall force is 70.0 newtons. So we do agree that the force in the x direction is happening parallel to the direction you want to go, and in one passing from one side of the yard to the other, you're moving 10.0 meters. So applying this to the work equation, force cosine theta times distance My force is going to be 70.0. My cosine is going to be of 46.5, and I'm moving 10.0 meters. When I solve this out, 70.0 times cosine of 46.5 times 10, I get a total of 482 Newton meters. Rounding to 3 sig figs because second semester sig figs still have not gone away. So at this point in time, I believe you are ready to pause the video and attempt these two sets of problems. Page 162, 1 through 4, and page 163, 1 through 6. Those questions just have to do with force and work, and we will correct those on Wednesday.